to lesson 6.4 on hyperbolas. This is the first day of hyperbolas of a two-part lesson. So today's objectives are to graph hyperbolas and write equations of hyperbolas. So before we get any further, let's define what a hyperbola is. Two ways to think about it. If we think back to our double cone, the hyperbola is what happens when I have that double cone intersected by a plane, and that plane happens to be parallel to the height of the cone. Now this is different, so it's perpendicular to the circular base and following that same along this height. The other way we can think about it is it's the set of all planes and a point in a plane such that the absolute value of the difference of the distances from any point on the hyperbola to any two given points called foci is constant. Now it's similar to our ellipse definition, except the difference is that this is a difference, okay? In the ellipse definition, the formal definition, it's that the sum of the distance is constant. Here, the difference. They say absolute value of the difference. That's only just saying, like, it doesn't matter which order I subtract them in. We're not going to worry about that net result being positive or negative. Some other vocab that we have is, we have vertices. Those are the points on each branch closest to the center of the hyperbola. We have what's called the transverse axis. That's the line from one vertex through the center to the other vertex. We have a conjugate axis. That's the line perpendicular to the transverse axis through the center. And we also have these things called asymptotes. The asymptotes are lines that the hyperbola approaches but do not cross. So we saw some hyperbolas in our Desmos activity, but here we're going to look at how to precisely graph them. So hyperbolas can be oriented in two different ways. We have left-right hyperbolas where you can see those two branches are on the left and on the right, and you can see we're approaching those two asymptotes. Those are in the format of an x squared minus a y squared. We also have up-down hyperbolas where I have it up and down. I know, right? And our equation looks more like a positive y squared minus the x squared. So which one is the one that's the order they're being subtracted is going to tell me which way it's oriented. So we're not worrying about which number is bigger, but rather which is the positive. Now, I'm going to show you why that's important. So if I had, for instance, x squared minus y squared is equal to 1. That is a hyperbola. So I'm doing a nice simple one, all in the same amount. Now, if I wanted to find the x-intercepts of that graph, when you find an x-intercept, you make the y 0. So I would have x squared minus 0 squared equal to 1. That's really x squared is equal to 1, and x would equal plus or minus 1. So this particular graph has two x-intercepts, one when x is positive 1, one when x is negative 1. When I want to find the y-intercept, we need to make the x 0. So I'd have 0 squared minus y squared is equal to 1. Negative y squared is equal to 1, means y squared is negative 1. And I have plus or minus the square root of 1, or plus or minus I. The fact that that's coming out as an imaginary number means I'm never going to cross the y-axis. So if my graph was on this one, see how I'm crossing the x-axis, but I'm never crossing the y-axis? This is saying never crossing the y-axis. So that's just a quick little verification of why x squared minus y squared is going to be a left-right, and y squared minus x squared is going to be an up-down. So we can ignore that video because I'm making this as a whole video anyway. All right. So example 1, find center, vertices, transverse axis length, conjugate axis length, and the asymptotes. Sketch the graph. I'm actually going to kind of do this in a backwards order. I'm going to make my graph and then I'm going to find things as I'm going. So notice here no co-vertices either. Important thing to note. That's the difference between an ellipse and a hyperbola. So my center is 0, 0, and that's That's because I have no transformations happening to that. There's nothing added or subtracted to either the x or the y quantity squared. I'm going to do just like I do with my ellipse and put a little x there. Again, I'm not going through that point. Now, the beginning part is going to feel really familiar, similar to an ellipse. I'm going to head the square root of 16, or 4, along my x. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to head the square root of 4, or 2, on my y. 2 and 2. At this point, if it was a plus sign between them, I would have my Stewie Griffin ellipse, and I would draw as best as I could an ellipse through those points. I do not have I have that subtraction. Again, this is a really important critical part. That subtraction there is what tells me I have a hyperbola. So what I'm going to do is make what I call the magic rectangle. And so I'm making a rectangle that goes through all those points. Lovely, right? Now, next thing, asymptotes. The asymptotes are going to go through the center and through the corners of this magic rectangle. Okay. It's nice to use a ruler on that if you have one available. Oh, sorry. It's nice to use a ruler if you have one available. So on these lines, I have one with a positive slope and one with a negative slope. And I'm rising 2 and running 4. So this has a slope of 2/4, or 1/2. The other one has a slope of negative. The other thing is we're going through the point 0, 0. So it has a y-intercept of 0. So our asymptotes are y equals 1/2 x, and y equals negative. Hopefully you understood where I got that from. I just used y equals mx plus b. When we do our asymptotes, we're either going to use y equals mx plus b, if we can see the y-intercept really nicely, or sometimes we're going to use point slope with our y minus k equals mx minus h, or so you could have the k on the other side as well. Okay, and oh, goodness, I'm bumping everything right now. All right, so next thing I need to know is if this is a left-right or an up-down. So I'm going to go back to my notes, okay, and say, since it's x squared minus y squared, which is like this, I'm going to have a left-right. So that tells me that I want left-right. So this is going to be one of my points. And from here, I'm going to kind of go up and approach that asymptote. And I'm going to go down and approach that asymptote. Do the same on this side. You don't want to cross your asymptotes. So that also told me my vertices. These big points on my magic rectangle, those are my vertices. So my vertices in this problem are 4, 0 and negative 4, 0. Now, the transverse axis length, that is from vertice to vertice. So that's asking how long is this length right here. Should make that a little wider, sorry. So that's going to be 4 on one side and 4 on the other side, which is a total of 8 units. Now, conjugate axis goes perpendicular to it. I'm going to do that in pink. Hopefully, I don't know, maybe you can't see that. Maybe I should do a different color. We'll go orange. So, right here. Okay, so that conjugate axis is 2 above and 2 below, which is a total of 4 units. And so we wanted to find the center, got it. Vertices, got it. Transverse axis length, conjugate axis length, and equations of the asymptotes. And that's it. And I have my sketch already, so I'm done. So pause the video and take a minute or two to try this problem. You actually tried it, right? Okay. So this one has a center still at 0, 0, right here. I'm going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to make my box. Liking the orange right now. I hope you can see it well. And then asymptote and asymptote. Asymptote. Okay. So again, I'm going through the origin. So my slope. Oh, well, I could write that y equals. I'm rising 4 and running 5, so 4/5 x and y 4/5 x. If you wanted to be fancy, you could also write y equals plus or minus 4/5 x. I know, so fancy. Next thing I want to do is put in my sketch of my hyperbola. Again, I have an x squared minus a y squared, which means I have a left right, which means I'm going to have that branch and that branch. Okay. So my vertices are at 5, 0 and negative 5, 0. My transverse axis, that's how far those 2 points are. Well, if there are 5 in each direction in the center, that's 10 units in total. And the conjugate axis length is this way. How tall is that box? And really that's giving us information about how steep the asymptotes are as well. And so that is 8 units. Now in this example, the transverse axis was longer than the conjugate axis, but that is not a requirement. Those are going to be dependent solely on the numbers in the denominator, and the transverse axis is going to be the one in which the direction of the hyperbola is opening. So it's opening to the left and right on this particular example. All right, so find the center of vertices, transverse axis length, conjugate axis length, and asymptotes. Sketch the graph. So I'm going to do the same pieces of information. I have a 0, 0, so I haven't had any that are translated yet. Now here I'm going up to, notice this square root of 4 is 2. That's going to give me that 5. Now, that's with the y squared. So that's why I'm going up and down 2. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to make my box. So I find these really fun to draw. They look really impressive too. Then I'm going to put my asymptotes in. Again, you use a ruler. They look really nice. Perhaps you can hear my daughter crying in the background. All right, so my slope here, I'm rising 2 and running 5. If you haven't noticed yet, notice, right? 2 and 5, 2/5. Coincidence? I think not. So we're going, and we also have a slope of negative 2/5 on this side. And so these two lines both go through the origin, so it's a y-intercept of 0, so y equals 2/5 x, and y equals negative 2/5 x. Now, tricky part here. Notice again, it was y squared minus x squared. So this is actually going to be, drumroll, an up-down hyperbola. I know. I was surprised too. So on that up-down, and you can go back to the beginning, it says, when we have an up-down hyperbola, we have y squared minus x squared, which is, well, I didn't go so far, which is what I have. So I'm going to have these two will be my vertices. Again, it's not based on which number is bigger, but rather which one's the positive part. So here's one branch, It's a really wide one. There we go. And here's the other branch. So my vertices here are 0, 2, and 0, -2. And our transverse axis length, again, it's between these two vertices. So how far apart are they? They are 4 units apart. Again, not longer, shorter, but which direction is it opening? And then my conjugate axis is going to be 10 units in total. All right, so pause the video. I know, you're surprised. And try this problem. Okay, got a chance to do it? All right, so I have a center here of 0, 0. Right there. And I'm going 3 along the y. 1, 2, 3. Going 3 along the x. Going 3 along the y. Going 3 along the y for that. I'm going 3 along the x for that. Going the same. Saying the wrong letters, but I'm going the same in all my directions anyway. So when I make my magic rectangle here, this time it happens to be a square. So if it had been an addition sign between them, instead of being an ellipse, it would have been an even more special thing. It would have been a circle instead of just, which really a circle is just a special ellipse where the denominators are the same number. Fun fact. Or where the foci are in the same point. All right, so there are my asymptotes. So here I have a slope of 1 and a slope of -1. So my asymptotes are y equals x and -x. This, because my y is the positive one, it's going to be an up-down. It's right here. And, oh, go away. Right here. So my vertices are at 0, 3 and 0, -3. I have a transverse length of 6 units, and I also have a conjugate length of 6 units. Okay. All right, now let's try some that are not centered at the origin. So here, this is a very tricky piece, okay? So my center, you want to say 1, 4. I know you do, because usually the x is first, but my x is not first here. My y is first. So we're actually a center of 4, 1. Because again, the x translation is how far I'm moving left or right, and the y translation is how much I'm moving up and down. And when we write a coordinate point, they always go left, right first, and then up, down second. Okay? So 1, 2, 3, 4, 1, right there, lovely. I have 7 for how far I'm going to go on my y. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I have 2 that I'm going to go on either side for the x. So we want to be careful because it's really easy to flip all the pieces around if I'm not reading it carefully. I could see somebody thinking that that first piece was referring to the x pieces, and it's not. So there's mine. Ooh, tricky now with my asymptotes. My asymptotes are no longer going through 0, 0. So remember, I had said that we could use a slope-intercept form, but I could also use point slope, and here's where point slope is going to come into play. The point slope looks like y minus k. The point that I'm going to use is the point that both of those asymptotes go through, which is right here, which is the same as my center. I know, I love it when things look nicely like that. So you can write y minus 1 equals, my slope here is going to be, I'm rising 7 and running 2, so 7 over 2, x minus 4. I'm also going to have 1 with the negative. Again, if you like to have your y isolated, you could also, and you could do the other way with plus or minus as well. My transverse oh, which way are we going? We are in up, come on, come on. We're in up, down. So we're up that way and down this way. So my transverse axis is 14 units in total. Conjugate axis is 4 units. Now, my vertices are not at 0, comma, plus or minus 7, because that would be if I was centered at the origin, which I'm not. My vertices are at 4, comma, 8 and 4, comma, 6. And that's this green point here and this green point here. It's also, I basically just took my y value and added 7 to it and subtracted 7 from it to find it quickly. Now, take a moment, pause the video, and try this problem. All right, so hopefully you've tried this problem. I'm going to start with my center. It's at -2, comma, positive 3. 1, 2, 1, 2, 3. There's my center. I'm moving 9 along the x. 1, 2, 3, 4, 5, 6, 7. 9 will be right here. Nope, just off a little bit. That's okay though. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 1, 2. If you didn't want to be off the graph paper, you could also have made your scale different, but I didn't really want to do that. It's only off by 1. It's all good. It's all good. All right. So since my x is the one that's positive and my y is negative, this is a left and a right, which means we're going to be right here. There's that. And right here. And here. So my transverse axis length is going to be 18 units. My conjugate axis length is 8 on one side and 16 in total. My vertices are going to be at -11, comma 3 and 7, comma 3. My asymptotes, I'm going to write it as 1. I'm going to go y equals this. My slope here is 8/9, plus or minus 8/9 x plus 2. All right, so that's graphing. And hopefully by now you feel like you have a strong grasp on graphing. So when we want to write the equation, we need to determine if it's a left-right or an up-down. We need to find the center, determine how far that magic rectangle is in each direction, and our asymptotes are actually going to be the thing that helps us with that, and fill in the values. And you can have, depending on if you are a left-right or an up-down like that. So first thing I'm going to do is I'm going to take this lovely graph and say, well, I know I'm a left-right, so, and my center is at 0, 0. So I'm going to have x squared over something minus y squared over something is 1. And see how I put those vertices in? That is 1, 2, 3. So this should be a 9 because 3 squared is 9. This is going to, and then I'm just going to make my rectangle. See where it hits that asymptote? That must be, because we know our asymptote goes corner to corner and then on forever, then that must be where it goes the other direction. Okay. So we are headed up 2, which means that denominator should be a 4. Done. Box. All right, let's take a look at this one. Pause the video for a moment and try this one. Okay. So my center here is now not at 0, 0, but rather at 0, comma, positive 2. So I'm going to tell, I also have an up-down, which means I'm going to have y first and x second. Or really, it's really that the x is the negative one, so a subtraction is usually written as second. And this will be y minus 2 quantity squared because of that translation up. Now, here are my vertices. Okay, so obviously we're going 1, 2, 3, 4, 5 on the y, which is 25. Y squared is 25. I'm going 2 along the x, and 2 squared is 4. Final answer. Alright, and this concludes our lesson 6.4 day 1 on hyperbolas.